Hi everybody, welcome to my very first YouTube video on anything Raspberry Pi or Python programming or electrical circuits. I'm going to kick things off with a simple, or what I have hoped to be simple, little coffee automation thing. My girlfriend and I drink French press coffee. We have this hopper fed burr grinder, which from the factory has a little slide potentiometer to declare for how much time it will run, and then the start button engages that cycle, and then it just runs for however much time. Turns off. Pretty simple. Yeah, that's that, and along with the electric kettle here, which I'm not trying to bite off yet. I don't know if any of you have looked into that. It's not nearly as simple as just closing a relay for a second. Once you tear that switch apart in there, you're in it to win it. You pretty much have to run the kettle with the Pi after that. So yeah, so here's what I got going on. I have a relay wired in parallel with the start button on my grinder, and so my first little project is to create a program that will close the relay at the time that I want it to, probably 8 in the morning for right now. And so then the grinder will kick on, do its normal thing promptly at 8 a.m. Yeah, without anybody having to touch it or be near it when it kicks on, because it's loud and first thing in the morning. It's not my fave. So here's the Raspberry Pi ZeroW. Picked it up about 6 months ago. Haven't really done a whole lot with it until the last week or two. I've just been trying to watch a lot of Python tutorials and do a lot of digging around on the circuits that I'm going to be using and stuff. But this relay is pretty sweet. They're super cheap. I bought like an 8 or a 10 pack off of Amazon. They're only a few bucks a piece, and they're already shielded. Yeah, you guys can see what's down on there. There we go. So pretty safe to use. I'm giving it 3-volt 3 supply, grounding to pin 6, and then VCC, or excuse me, the input, logical input, is set to pin 11. That's board pin 11. Alright, so let's go over to my Mac and I'll show you what I'm running for software. Okay. So here on my Mac, kick things off by opening an SSH session with my Raspberry Pi. At and I'm using -Y here to support X11, and I also have this X Quartz application downloaded because Mac no longer supports X11 GUI sessions, and so I'll show you in a second what this does for us. Now we're into the Pi, and I'll launch IDLE 2.7 for Python 2.7, and open a little program that I wrote for this. Okay, so you can see I have a bunch of stuff commented out, and that was useless code that was from other stuff I was attempting. Yeah, but I kick things off by importing time, date time, and schedule. I'm not even using date time right now, so it ends up being overkill. Actually, I'll just go ahead and get rid of that. this is a little slow going over the wireless network. Our wireless network is a little bogged down also anyway. Okay, so import time and schedule. I'm using the schedule module, which I actually didn't have. I had to install, and so that was done by sudo pip install schedule. And that was it. The Pi already had the had the library to install, or the module. Okay, so easy. And then I'm using the RPI GPIO library to do GPIO functionality. I'm using the board numbering scheme, and so I'm set up on pin 11, setting it to output, and then setting the initial state to 1, because the logic on my on those relays I purchased is such that output low closes the relay. You have to output high to open it, but you can imagine that if the relay closed and my grinder went off every time this program started, it would be a little annoying. So yeah, sets initial to 1. Here I'm defining a function grind. It's pretty simple. It just sets the output pin 11 to 0, sleeps for a half a second, output pin 11 to 1, and then it prints us a little message, but it actually won't be printing anything, because as you saw, the Pi doesn't have a display hooked up. So then I have this one schedule event right here, schedule.every.day.at. I'm telling it literally 8 hours do grind, executes or calls this function. So that occurs, and then I'm setting this variable mode to 1, only to keep my while loop open right here. So while mode is greater than 0, it's just going to keep on flopping back and forth between these two, attempting to run any pending schedules or scheduled events such as this one, and then sleeping for a second. And when this runs, it takes up, it's nothing. It's no big deal. So okay, so sudo python, where am I at? Desktop projects, coffeetime.py, and it's running. Okay, so that program is running, coffeetime.py, and so this thing will just sit here until 8 in the morning. That relay will click real quick, the grinder will kick on, and unfortunately I'll still have to actually get out of bed and like put water in that thing and hit boil and wait for it, and then put the grounds in the press and wait for that to steep. But when I figure out a way to automate all the rest of that crap, I'll let you guys know. As far as memory is concerned, this program takes like no memory. I watched the usage graph run while it was running, and it just runs like it normally does. So and then it's yeah, as far as I hope, this Pi could sit here and run this indefinitely. Alright guys, thanks for checking out my video, and hopefully there will be many more and many collaborative attempts at making ourselves better at this stuff. Alright, have a good one.